Okay, so just as a quick reminder of what we talked about in class, what we have here is the direct effect of B on A, and what that means is this includes all effects of B on A through however B does influence A, but in this specific case, what we're assuming is that there is no moderating influence. Or another way to think about that is that the effect of B on A is solely attributable to B and nothing else. Or that it's direct to A, it doesn't go through any other, it's not filtered essentially through any other factors. So that's the overall effect. And then what we're doing when we're testing for mediation is we are and so what we have here by comparison is what we test for when we look at mediation. And so what we're going to do is we're going to decompose that full effect, the overall effect that we looked at in the previous slide. We're going to break it down into two constituent parts. One is the indirect effect, and one is the direct effect. And the way that we do that is you see we kind of have two dependent variables here, C and A. And so in order to test whether there's a mediating factor, we're going to regress, essentially we're going to regress C onto B. And if there's a significant association, then there's evidence that of a mediating influence. So that's the first step. And then the second step is we will regress A onto C and B. And we're going to really kind of focus on what happens to B when we do that. And what we're left with will be the decomposed overall effect. Okay, so before we get into the numbers, I just want to go quickly over what's going on here. I don't want anyone to think something weird is happening. I just called in the data. You'll see in a second that I just opened the data set, and I just changed the name essentially of these variables. I just cloned them so they had exactly the same characteristics, and so there was no need for recoding. And I just gave them like easier names because I thought that would make it easier for writing in the syntax. So back to what we have going on here. You'll see that the first thing that we're going to do, right, this is going to give us the overall effect, and we're going to get that by regressing delinquency onto victimization. And we'll go through the results in just one sec. And then, but that's the first step. And then you see the second step, we are regressing anger onto victimization. So that's the B to C path. And then we include both predictors in the model. And what we will see then is whether or not there is a significant mediating influence. And we're going to do that by kind of taking a closer look at, again, what happens to the coefficient for victimization. Down here at the bottom where it says PCOR, that is a command that will calculate a partial correlation coefficient between delinquency and these other two factors. And the reason why this is included, it doesn't change anything, but you'll see when we get to the results part that the partial correlation coefficients are going to be very similar to some of the estimates that we generate here. And so I will be right back with this data. So if we now look at the second part of the do file, you'll see that in the next step, what it asks us to do is kind of go through the same process, but including models that are more fully specified. And they include just sort of an array of other characteristics that may be predictive of delinquency and anger. And so what we I will not go through these. I try to leave as many notes as possible, but I will let you run through those steps. But one thing that I did want to show is that there is this command here that is called SG Mediation 2, and I will put the link to that. You have to download it from. You can just put a stata command and it will download it. But so I'll put that into this do file. But essentially, what we do here is we do it all in one step. Right? So we're going to look for mediation. Right? The mediating variables anger. The independent variable of interest is victimization. So victimization is mediated by anger. And then CV are just a bunch of controls. And when we go through this, what's cool about this is that it runs all the models, and then it gives us the calculated direct and indirect effects. So just hold on one quick sec. All right, sorry. So here, what we're going to do, this is the command that you're going to want to issue, and once we do that, we will have a new command, a new program command that we can call, and that is called SG Mediation 2. And when we run through this, what we should see are results. If we kind of scroll up to the top, right where we issue that command, you see it tells us what it is doing. And so what it's doing here is it's running that first path, right? And so we have this effect here that is the overall effect. And you're going to see these numbers are very close but a little bit off. And that has to do with how cases are being included or dropped. And there's a small difference in sample sizes that's responsible for this. So they just use different techniques in their estimation. And so here you see the effect size is about the same, right? It's statistically significant. And then when we go down to the second step, right, it kind of runs through this. We now see this, the effect of victimization on anger, right, net of all of these other characteristics. And you see here, what we have is the full model. And what we see here is, again, we see that the effect size shrunk considerably. The beta weights are approximately the same. They're in the same ballpark. As we will see in just a second. And what we see here is this. This is the right. What this Sobel-Goodman test, and that's the SG from the SG mediation, is testing is whether or not the mediation was statistically significant, right? So the change, how much of the effect is channeled through the variable anger. And so here's also in the do file, you'll see that this coefficient is the effect of B on C, right? And so this coefficient is the effect of, in based on our model, right? This is the effect of anger on delinquency. And when we get the indirect effect, what we will do is we will multiply 1.695 by 0.092, and that gives us 0.157, and you see here. So that is the indirect effect. In order to get the direct effect, what we will do is we will subtract the portion that we know was that's indirect, right, that was mediated, from the overall effect, and the difference between the two is the direct effect. And so these are just kinds of statistics that are easy to calculate, but they just kind of tell us about relative size and how much mediation how much of the total effect was mediated. And so that is the mediation portion of the video. So if you have questions when you work on it, please let me know. So what we're going to do now is we're going to switch focus to from mediation to moderation. And so again, this is where we include interaction effect. And so I'm going to go through these notes, but again, all of these will be included in the do file on Canvas. And so what we're going to do before we test for an interaction effect is we are going to let me just scroll up. We're going to adjust the both of the variables we believe are interacting. So in this case, the N indoors, that's number of victimizations, and P super V is parental supervision, and it will include the same dependent variable and all of and a bunch of other controls. But we want to there are two kind of main ways we can adjust the values of the variables we include in the interaction. So first and foremost, right, we can center a variable on its mean, and so we will get the descriptive statistics for victimizations, and then we'll create a new variable with the underscore CENT, indicating it's centered, and we're going to take the value minus the mean. So this R parentheses mean, it's sort of this internal stata command that will allow you to call in what is called a scalar and include that in a calculation. So we'll do that for both of them, and we do this mostly to help control or help limit issues related to multicollinearity, which can affect estimates and standard errors. And so what we will do here is we will then, once we have these two centered variables, we'll create a whole new variable. And you'll see this is victimization by supervision. And the way that we do that is we're just going to multiply both of those newly created centered variables. And then we will run the regression, and we'll be able to tell if there is evidence of a multiplicative or a conditioning effect. One thing to point out, and I don't that sometimes can get a little bit confusing, is even though, or specifically when we are testing for an interaction effect, in order to do so properly, not only do we have to include the variable where the two are multiplied, but we have to have each of the independent effects included in the models. And what I mean by that is we will include both the number of victimizations and parental supervision as their own variables, so the independent effects, as well as this newly created variable that is the product of the two. And so that's the first way that we can create the interaction variable. There's a second way, and I guess there are two more ways. One is we will create z-scored versions of those variables, and then the variable that we include in the model statement will be those two z-scores multiplied, right? So either way, they both, we can talk a little bit more about why you might use one or the other, but essentially it's not going to change the math, right? It's not going to change the results. It's going to change a little bit of interpretation. And so what we have, so we just have to keep that in mind. We also could have installed this a do file called z-score, and that would allow us to create a z-score just by issuing a single command. We wouldn't have to do this egen business, and we can include multiple variables at the same time. All right, so what you will see when you go through and run the models, again, as I mentioned, there is nothing that's going to be different substantively or mathematically about the models, whether you use a z-scored interaction effect or just a centered interaction effect. They all will produce the same they'll all produce identical results. So take a look at that. There is just, again, two ways of doing the same thing with a slightly different interpretation. What we also see here is that there's this technique here called nest reg, and what that command allows us to do is, for our when we run our regression statement, we can include blocks of predictors as a means of telling whether or not that group of variables as a whole has a significant impact on model fit. And so what you'll see is that it'll provide statistical information for each one of those blocks and whether or not it is statistically meaningful, and it will also produce the estimate the regression as well. Finally, there is one other way that we can estimate this, and in a way it is the most, it could be the most straightforward, but it takes a little getting used to, and that is we can create or tell Stata to create an interaction effect on the fly. And the way that we do that, you'll see in the statement, is we identify the type of variable, where C indicates it's continuous and I indicates that it's categorical. And then when we get to the two variables we think are going to be interacting, we will put two hashtags between them, and that tells Stata to estimate an interaction effect. And then as we go down here and near the end of the file, these are just ways of kind of taking a closer look at what does an interaction look like, or what does it look like in terms of the differential estimates that it creates. And so this first part creates a dummy variable, and in a sense, it will predict models based on different models for those who have either high or low parental supervision. And we'll go through that. And then finally, what we also have is a way to visualize. And this was the image on the very last slide that we looked at in class. And that was based on this command here, margins. And we're going to talk about margins with a lot of the estimates that we do. But what this allows us to do is to generate predicted values at different levels of both victimization and supervision. And specifically, when we look at this command, what it's telling us is that for every, this will estimate a value starting at 0 and ending at 16 with 4 estimates in between, right? So we're going to have an estimate at, so what that is actually a total of 5 estimates. So it's 0, 4, 8, 12, and 16. So it's 5 of those. And then we're also going to sort of include not only how, the number of victimizations, but also level of supervision at each one of those levels, and in terms of the effect on delinquency. And so this first command, margins, produces a whole bunch of numbers. I went ahead and estimated the models, and I'm not going to go over every single one. And the reason why is because they're all different ways of doing the same accomplishing the same goal. But I do want you to get used to it, and I would like for you to run those models just so you kind of see where these numbers are coming from. But basically, what we see here is that when we estimate the full model, and including both the independent effects and the interaction effect, we see that all of them have a statistically significant effect on delinquency. And what we're going to look at in just 1 second, just right below this is from the nested approach, which can be very helpful when we're trying to identify whether or not specific groups of variables or a contingent of predictors together are systematically associated with the dependent variable. And so here's what's kind of interesting, in that we see that this gives us the breakdown of the block. So the first one had essentially all the controls, and you see that it does have a significant contribution to model fit and explains roughly 10%. And then when we include just one other variable, and that variable being victimization, you'll see that the R squared jumps up 20%. So just that one variable alone explains 20% of the variation, or almost 22% of the variation in delinquency. So that's a very strong association. And then here, the third block includes parental supervision and the interaction. And you see here we have less of a large effect, but still it's statistically significant. So sometimes folks will refer to that as being statistically significant and substantively meaningful, or a non-trivial effect. And so that is when we run the interaction effects. And I just wanted to kind of jump down to the margins so you can see what we're talking about. And so here is the command where we call margins for victimization at these different levels, and then parental supervision. And when we kind of go down, you'll see for each estimate, there'll be a total of 15 estimations, one with victimization at 0 and parental supervision at 3, 6, and 9, then at 4 victimizations and the same levels of parental supervision, and so forth. So these are the values for all of the predictions. And when we take a look at the what I should say, these are all of the values that are used as predictors. So the model is fully specified. And when we look at the command, let me scroll up real quick. When we look at the command, we are only adjusting values for the victimization and for parental supervision. And what that defaults to is that every other variable is kept at its mean. So it just kind of holds all of those right at their mean, so we can see how much difference or how much change there is at these different combinations of parental supervision and victimization. And when we kind of roll through all of this, we will ultimately end up with a chart that looks like this. And this was on the last slide, but I thought it might be interesting, or it might be helpful, hopefully it's both, to see like what is it we're doing when we're using that margins command, and what does it look like. And so here, right, we have slightly different slopes for these. And so, right, when there are these differing slopes, what happens is, or what that is an indication of, is that the values, the effects of all variables are not the same at all levels. And so, in other words, that is an indication that there is an interaction effect. I wanted to show one last thing, and that is I also created a spreadsheet that kind of goes over the calculations, right? Like what even are these? Where do these numbers come from, right? The margins values. And so, we'll take a quick look at that in just a sec. So in this spreadsheet, what we're looking at is a way that I came up with to kind of show how these margins values are generated, because they can seem a little bit confusing, and it's not always clear, or at least might not be clear where these numbers are even coming from. And I just wanted to show that these numbers are generated based on just the same kind of way we predict y hat, and that is we multiply a value by the coefficient by a value of x, and then we sum up all of those numbers to get the single estimate of y hat. So here what we have is we have the number of victimizations. So for each sort of grouping of parental supervision levels, the victimization values are going to be the same. And the way where we get those numbers is we're going to multiply the number of victimizations by the victimization coefficient. And so for each level of victimization, the contribution of victimization to the estimate will be the same. It'll vary across victimization levels, but within levels they'll be the same. And you see that here. What we also have are the supervision levels. And so what you see here is we're going to multiply the supervision level, so 3 by the supervision coefficient, and that will generate the supervision portion of the estimate. And then finally, and this is where it may get a little bit tricky, we don't multiply these two values together to get the interaction term, this value here, 0.4227. Instead, what we do is we're going to multiply the value for the supervision level, which is 3, by the number of victimizations, which is 4. So we have a product term of 12, and we're going to take that value 12 and multiply it by the interaction coefficient. So if we look here, you'll see that we multiplied B5 by 12, and so B5 is the interaction coefficient, and we multiply it by 12, which is the interaction value. And so moving up, we have 4 victimizations still, but a parental supervision level of 6. And so we're going to multiply the interaction coefficient by 24 instead of 12. And you'll see here that this value for 4 victimizations and 6 parental supervision level of 6 is twice that of 3. And so again, what we do here is we're going to multiply victimization by parental supervision, and we have 36, and then we're going to multiply it by the coefficient here to get a value here. Once we have filled in the values for the interactions, we are going to sum each of those columns, and that will give us our margins value. And so, for example, if we look at the first 3 and the last 3, right? So we have 0.28, 0.57, and 0.85. And so if we look back here at the first 3, we have 0.28, they have 0.30, we have 0.57, they have 0.59, and so forth. So what we're seeing here is that our values, they're not identical, but they are very, very close. And so that difference that we observe is due to rounding error and not a substantive issue. And if we look at the last 3 values, you see we have 4.9, or 5.0 if you round all the way up, 0.69 and 0.89. And when we look at the spreadsheet at these last 3, you see we have 4.94, 0.69, and 0.89. And so again, these values are almost identical. And the where we got them was using, again, the combination of coefficients and victimizations and supervision levels. And one other thing I wanted to mention was we don't include values for all of the other estimates, predictors in the model, because when we ran the margins command, we only included 2 variables that we wanted to vary. And what that means is, by default, all of the other predictors are held at their mean. So that's good for us because that allows us to compare these numbers. These numbers are all comparable because they're based on the same model estimation. But so they're based on the same model estimation, but because all of those variables are the same in each model, they're kind of a constant. They become a constant, and so they kind of drop out of consideration. So that is where these margins values, how they're generated in this case. If you have any questions or if anything comes up, please let me know. And I hope this is helpful. But I will see you guys next week.